All right, guys, this is chapter 12, section 2 on chords and arcs. We'll get a visual, first of all, of what they both are. So here's our circle. A chord is a segment that runs from one side of a circle to the other side, like that. We'll learn a little bit of math about them. And then, opposite of that, a arc is formed from the center. It's called the center C there. The arc is this little piece that runs from there to there. So if you think about a circle having 360 degrees around it, that gives you an idea of how much your arc is. Your arc is going to be equal to the measure of this central angle right here. So there's the central angle. And this arc will be equal in degrees to the central angle. Okay? And we also designate it in degrees. So if this central angle is 40 degrees, then the arc is also a 40-degree arc. All right, so similar to arcs, which make more sense, there's some more rules regarding chords as well. Basically, an arc is equal to every other arc formed from the same central angle, and the same can be said of chords. If I've got a central angle there and the chord running across it, and this is congruent to it right here, if this is congruent to this, then that chord is congruent to that chord. And so you can see a little bit of the math there. Now, similarly, you can go backwards from that, where congruent chords make congruent arcs. So you can see some of the math that will be created in there. Trying to see if there's anything else that's necessary here. Let me go ahead and give you a visual of 12-7 as well. So here's another circle. Okay. If chords are equidistant from the center, that means that the chords are congruent. Here's an example of that. Here's a chord here. Here's a chord here. Here's the center of the circle there. And if, remember, you measure distance. Actually, you know what? I'm going to change colors to make it a little bit more sense. There's my center there. Remember that we measure distance on a perpendicular. So if you were to draw a perpendicular of both of these and show it as being perpendicular, and that was congruent to that, then you know that the chords are also congruent. So if this was chord A, B, and this was C, D, you would be able to write that AB is congruent or equal in measure to CD. And you could do some math like that. That's theorem 12-7 and its converse. We can call the center O. Okay. We're not going to do a proof of that, although there may be some minor things that show up in your Math Excel regarding minor proofs, but there'll be ones where they've already been partially filled in if there is any. So not really doing a lot of it. And later on, we're going to learn some math related to these chords and arcs too. So that's why we've got to learn the definitions and how they fit. All right, so here's a problem number 2 in your books. I'll start off with blue this time. So here's a circle. And it says we've got the center is O. But then we've got some chords in there. We've got a chord, and let me change colors again. We've got a chord that runs across here, and this one is called R. Whoa, that was not what I meant to write there. We'll call that one R, and that's S right there. But then just like that, we're going to go from here to here, and that's going to be our P. All right, then we're also given this visual. Let me change color again to make it a little bit easier to see. From there to there, and from there to there, at right angles, we're told that those are both 9. So 9 and 9. And we're told that this, let me go back to red here, is congruent to that. And those are both 12.5. Okay, so that's a 12 point. I have to erase it because it's just not wanting to write real small for me. That is 12.5, the left piece and also the right piece. And this is point Q right there. So PQ is congruent to QR, and they're both 12.5. And then the question is, what's the length of RS? Okay. Well, here's how you would go about figuring this stuff out. First of all, PQ is congruent or equal to QR. So they're both 12.5. Okay, so that's fairly easy to see. But that means that PQ plus QR is 25. So PQ plus QR equals 12.5 plus 12.5, which is 25. And we know that PR, let me erase that. PR is congruent to RS because of theorem 12.7. They have the same distance, 9 and 9 from the center at a perpendicular. So PR is equal to RS. So RS also has to equal 25. And if you were trying to find the length of RS, that is the logic that you would use to figure it out. All right, a couple of other theorems that are related to these. Let me erase this real quick. And again, I'm going to refer you to your book. I'm going to do a brief teaching of this, but do more in-depth looks at some of these problems in your book, and it'll help. All right. If a diameter is perpendicular to a chord, then it bisects the chord. So let's think and see what that visual is. We've got a circle. We've got a chord right here. And if I were to draw a diameter across here, and it's also perpendicular, this theorem states, this is theorem 12-8, states that this has to be congruent to that. So you can kind of see the visual and see why. You'll need to look at theorem 12.8, maybe write it into your notes to make sure you can use it for a test. Now, if a diameter, this is theorem 12.9, bisects a chord, this is basically the converse of 12.8, then it has to be perpendicular. So you've got both ways. Theorem 12.8 says if the diameter is perpendicular to the chord, then it bisects it. Then the converse says that if the diameter bisects the chord, then it's perpendicular, so you can go either way. Theorem 12.10 states, in a circle, the perpendicular bisector of a chord contains the center. So if you have a chord, like in this right here, and that chord has been bisected by another segment, like this segment right here, then we know that the center is somewhere along that segment. It doesn't really doesn't tell you mathematically where it is. You just know the center is on that segment. So there's theorem 1210. They're all kind of intertwined with this idea of diameters bisecting a chord on a perpendicular level. It cuts that chord in half. All right, so now we've got a problem in problem 4 that we'll go through as well. Give you a little bit of help for some of your homework using all this stuff. We've got a circle. This circle has a center K, and it's got a radius to there, and then a chord across there. Erase the little extra that went past. The radius is K to L. N is that point right there underneath. So there's N, and M right there. Okay, and we know that this little section says, what is the value of each variable? Oh goodness, it is so small. I'm just going to say that that's X. It's actually, I think the book calls it an R because it is a radius. So we're going to say that that's an R. We're going to try to find that measure R. And then it also says that from L to M there is a distance of 14 centimeters. Okay. And we know that from K to N right there, that is 3 centimeters. All right, so let's start bisecting all this information and figure out what we've got. If I draw and make this a right triangle right here, well, did I just go from the center across my chord? And doesn't that mean that LN is now congruent to NM? So if I can find LN, all I have to do is double it, and I've got the length of LM, which means that doesn't LN have to be 7 right there? Okay, so let's stop and think. LM is 14. Half of 14 is 7. We know that LN has to be 7 because KN bisects LM. So now all we've got to do is the Pythagorean theorem. 3 squared plus 7 squared equals my R squared. Okay, so 9 plus 49 equals R squared. R squared equals 58. Take the square roots of both sides. R equals square root of 58. And if they asked for a estimate, you could estimate that. I think it's around 7.6. If they ask for a radical format, then just leave it as a radical. All right. Well, that summarizes the majority of this lesson. Again, I tried to look at it pretty quick. I've only got 15 minutes in these lessons, but you understand how chords and the arcs work. We didn't spend a lot of time with the arcs. That's going to be coming in some future sections, but be ready for it. There will be probably a few questions about the arcs as well. All right, good luck, guys. Remember that this assignment will be due Thursday at 4 o'clock. Hope y'all are having a good week.